So as we move on to the double angle formulas, again, you can just Google what these formulas are and you can use them, but it is nice to know where they come from. And as long as you understand, and we're going to start with double angle for sine, and you understand that that's just the same thing as sine of theta plus theta, then it makes perfect sense if you follow from the previous unit that this is sine of theta, the first angle, cosine of theta, the second angle, plus cosine of the first angle, which is still theta, sine of the second angle, which again is still theta, and addition and multiplication is commutative. So really we have one sine theta cosine theta plus another sine theta cosine theta. What we have is 2 sine theta cosine theta. So this is typically how we write the double angle formula, just like this. And I can explain it in other ways if anybody's interested. But usually this is fine. Like just show it one way and then we're good. And I can do the same thing for cosine. And understand that cosine of 2 theta is the same thing as cosine of theta plus theta. And if we follow from our sum formula from the previous unit, then it makes sense that you have cosine of the first angle times cosine of the second angle. Remember, it's minus with the plus, or you could just Google this formula, which is totally fine. Sine of the first angle, sine of the second angle. In other words, it's cosine squared of theta minus sine squared of theta. I like this formula the most. I don't know why, I just do. But if you Google, you will see that there's other formulas as well, which is why this box is so large. And the reason why there's other formulas as well is because some people might just prefer to write it differently. And that other method of writing is examining the fact that sine squared of theta plus cosine squared of theta is equal to 1. We learned that before. So what they do is they do 2 different things. They rewrite the formula as, I don't want to write it that way. Let's start with cosine squared. That cosine squared of theta is equal to 1 minus sine squared of theta. So what they do is they replace this cosine squared with 1 minus sine squared. So what we really have is this formula, that cosine of 2 theta is equal to 1 minus 2 sine squared of theta. So this would show up on your formula sheet as well. Or you might see the problem written this way, where sine squared of theta is equal to 1 minus cosine squared of theta. And maybe I'll show this because you have to distribute. So replace the sine squared with 1 minus cosine squared. So we're looking at this cosine squared minus the quantity, because it's minus sine squared, so it's the quantity of 1 minus cosine squared. So when you distribute that minus in there, what you'll get is that cosine of 2 theta is actually equal to, they typically write it this way, the 2 cosine squared, because it's 1 plus 1. Hopefully that makes sense, and then minus 1. So there's definitely a reason that there's 3 different formulas for a double angle of cosine. And then tangent, I'm just going to go to the answer key because I always mess this one up. So you can see this person's way of working through it is writing the problem this way. Now, if I were doing this, I'd probably rewrite it as tangent of 2 theta is equal to sine of 2 theta over cosine of 2 theta, and then simplify it. But like I said, I always mess this up, which is part of the reason why if a math teacher messes it up, and I literally get paid to do this, it would kind of be, I don't know, hypocritical might be the right word. to expect you guys to memorize these things. So there's definitely a place to understand where the formulas come from. But then at some point we just have to apply the formulas, and that's where I'm at. I want you to apply these formulas. So hopefully you had enough time to hit pause, write those down as I move on to actually applying these. So if we're looking at this and we have sine of theta is negative, well, let's think about that first. Well, if sine is negative, we're in either the third or fourth quadrant, not the first or second. But tangent is greater than 0, so tangent needs to be positive. That's either the first or fourth. Wrong. First or third, not the fourth, which means that theta by itself is in the third quadrant. Let's get a little bit more detailed about that. Okay, what am I talking about? Is where that's 180 degrees to 270 degrees. So generally speaking, if I were to double that angle, okay, so all I know is theta is bigger than 180 and smaller than 270. Well, if I double 180, I get over to 360 degrees. So when I do the double angle, it's at least 360. Now be careful, because if you double 270, 270 times 2 is 540. So that's like a full revolution. And then over here. So sine, it's going to be, let me put it this way, that all I know is that it's bigger than 360 and then smaller than 540. But I have convincing evidence, at least for myself, that sine of 2 theta should be positive. I don't know yet if cosine of 2 theta should be positive or negative, because the first quadrant cosine is positive, and the second quadrant cosine is negative. And then same thing, I don't really know tangent yet. Okay, so we're in quadrant 3, and I think the picture is better than your explaining in words. That's my opinion. Your future professor might not agree with me. So we established we're in the third quadrant, so I want you to draw the angle. The reference angle would be here, made with the x-axis. And then I want to see the triangle that sine is opposite over hypotenuse. And the reason why I want to see that, let me switch back over to orange, is because now we can establish that adjacent, because it's a 3, 4, 5 Pythagorean triple. So now we also know that cosine of theta needs to equal negative 4/5. I know the problem doesn't ask for it, but we need it down here. And then tangent of theta is opposite over adjacent would be 3/4. And negative over negative is positive, and we're back to tangent being positive, just like we said we would be. So as we do the problem, let's switch back to blue. And we did sine of 2 theta. What we know is that that is 2 sine of theta cosine of theta. That's the formula we already learned about. So it's 2. Sine is, I already forgot what it was, negative 3/5. And cosine was negative 4/5. So if it helps, put that 2 over 1, because when you multiply fractions, you just multiply numerators with numerators, denominators with denominators. So I've seen students have to do that to write 1 times 5 times 5 is 25. And then 2 times 3 is 6 times 4 is 24. And I mentioned it earlier that we should get a value for sine that's positive. And my reasoning from earlier still holds true. And positive times negative is positive. One more thing before, so that's sine of 2 theta. We'll get to that, the bulk of this lesson in a second. But I do want to mention that your answer should be smaller or equal to 1 still. All of our answers should be smaller than or equal to 1 and bigger than negative 1 while I'm mentioning it. So if I do cosine of 2 theta, I mentioned it earlier that I prefer the formula that you do cosine squared minus sine squared. You don't have to. That's just I just prefer that one. It makes the most sense to me, so that's the one I go with. You don't have to do it my way, but my way does work. So cosine was that -4/5. Well, once you square a negative, it becomes positive. So 16/25. 4 squared is 16, 5 squared is 25. Minus sine was that 3/5, but 3 squared would be 9. 5 squared is 25. The denominators are the same, so we can subtract. 16 minus 9 is 7, I believe. Still less than or equal to 1. I actually don't. I'm just pointing out that it's less than or equal to 1 to help remind you as we learn new things. Now, again, I'm not a big fan of memorizing that tangent formula, but you can use it. But the reason why I like to just know that tangent is sine over cosine, well, we just found out that sine over cosine is this. So it's 24/25 over 7/25, which also would be the same as doing 24/25 multiplied by the reciprocal, which is 25/7. And I meant to change colors, but I didn't, where the 25's cancel. And you may remember earlier I talked about how those cancel. And we get a number that is larger than 1. Which, okay, that's fine. Tangent can be larger than 1. So as we write this out from least to greatest, I think I made a comment to a few of you about just the way that you write it, is I'm fine if you just label in order. I also like to see the less than symbol. That's nice to see. So the smallest number was cosine, and then sine, and then tangent was the largest. And you can deduce now with confidence what quadrant we end up in, because all 3 of these are positive. 2 theta must have ended up in the first quadrant. As I predicted, I said it's either the first or second, but now we know for sure it's in the first. Now, I think I have enough time to do this next one. Now, to me, the more complicated formula in this problem is the right side. So another thing that is complicated for some students to remember is, so I'm going to start with the right side with verifying this trig identity, is that cotangent is the reciprocal of tangent. So this is a true statement. Well, that's where you would want to go back to your formula sheet, whether you Google it or you have one ready, print it out, and ready to go, and establish that. And I'm going to go back to formulas. That if we're doing the reciprocal of tangent, then we just need to flip this. So what I'm talking about is we'd have 1 minus tangent squared in the numerator and 2 tangent theta in the denominator. Tangent squared over 2 tangent theta in the denominator. And I think you might notice then the 2's will cancel there. And as you're looking at this, somehow we need to establish that that equals cotangent of theta minus tangent of theta. Well, as I'm looking at that, I would think this as dividing each piece. Tangent of theta minus tangent squared of theta over tangent. This is how I would do the problem. You don't have to do it my way. But a lot of students are familiar that if the denominators are the same, we can put them together and just subtract the numerators. But students forget that you can go this way as well, where if you have only one denominator, you can split them up. That's what I'm doing here. So then from here, remember the reciprocal of tangent, well, that is cotangent. And then here, we can cancel out one of those tangents, because remember, tangent squared is tangent times tangent. So you're just left with one tangent. So notice I started with the right side of the equation, I ended with the left, and we verified that identity. So go ahead and hit pause, make sure you understand this. You might do this, it's slightly different. I could show you the answer key, which might look slightly different. And then I will see you in the next video to do a few more problems before the homework.